Welcome to the Combustion Analysis webinar presented by DEWESoft USA. DEWESoft designs and manufactures versatile and robust data acquisition systems that make test and measurement as simple as possible. Our instruments and software are designed to be fun and easy to use. DEWESoft systems are modular and expandable and can work with any signal and sensor. In today's webinar, we will discuss DEWESoft's easy-to-use measurement system for internal combustion engine measurement, analysis, and thermodynamics. We will present how our test system offers a complete combustion measurement and analysis system for internal combustion engine research and development, optimization, and testing of ignition systems, exhaust systems, and valve control gear. At the end of this session, we will have a time of live Q&A. We will begin after the 40-second countdown. So warm up your coffee, grab a snack, and enjoy today's webinar with your technical lead, Primož Gorenšek.
Hello and welcome to today's webinar about combustion analysis. My name is Primož Gorenšek. I'm an application engineer here at DEWESoft, and I take care of automotive applications, including combustion analysis. In this webinar, I will show the basic theory of combustion analyzer, what it is used for, and how it is working inside DEWESoft. We will go through what are the combustion analyzer requirements, so what are the minimum inputs needed for combustion analyzer to run. I will explain some of the top features in the software of DEWESoft Combustion Analyzer. I will touch on the outputs that are standard for the combustion analyzer. I will show different options how to transmit combustion data that can be used with other systems, and also explain how this can be nicely combined with other modules inside DEWESoft. At the end, I'll also explain some of the new planned features we have for Combustion Analyzer in the future. And after the conclusion, I will move on to the software. And on this small actual engine demo toy, I will show how Combustion Analyzer can run. And I will show this also in combination with power measurement, so you can see an actual hybrid engine measurement. To start with, Combustion Analyzer is a bit different than all other modules inside DEWESoft. The main difference is that Combustion Analyzer relates pressure, temperature, injection, all of the analog measured inputs from time domain to angle domain. So in every engine measurement, we are not interested how everything was changing over time or what were the measured values over time, but instead we want to see how pressure, for example, was changing or what the pressure values were in relation to current crank angle position. So our combustion analyzer can only be used in reciprocating piston engines. We do not support rotary engines in this case, so mostly this can be used on every 2-stroke or 4-stroke engine inside a car, ship, airplane, lawnmower. We do combustion analysis with our systems from the biggest ship engines in the world to smallest RC engines. So the possibilities are unlimited, and at minimum, what is needed for the combustion analyzer to run is one angle sensor on the crankshaft and a pressure sensor inside the cylinder. And then the volume is recalculated out of the known geometry of the engine. a minimum of one angle sensor is required to have one reference pulse each revolution. And for this, we support any encoder. So these are 2 pulses with 1 0 pulse every revolution. We also support CDM with 0 pulse. So this is just one wheel with constantly spaced pulses. Usually it's 360 or 720 pulses and one additional 0 pulse each revolution. The Tahoe is also supported, although not really recommended since this is really low accuracy combustion analysis. What is most often used and something that is also supported is the gear tooth sensor, either with missing or double teeth. And at this part, we just this year made some additional development, and we now support every kind of gear tooth combination. And this can be missing teeth with one gap or with multiple gaps. They can be equally spaced between each other. They can have different number of teeth between gaps. Because of this, we can now support almost any kind of OEM sensor on the engine directly. We also support pressure sensors with direct charge inputs. So our amplifiers have direct charge inputs and can be connected directly to the instrument without any inline amplifiers. And this is, of course, a huge benefit if you want to do knocking detection or just see the raw signal without having any filters on it. We also support voltage output or current output if it comes from some preamplifier. And additionally to what was mentioned, our system can be expanded to an unlimited number of channels. And this is not just tens of channels, it's hundreds or thousands of channels that can be connected together. Either analog, CAN, CAN-FD, LIN, FlexRay, Modbus, OPC UA, etc. And together with all the analog channels or digital channels, we can also connect video, GPS recording. So this can also be nicely coupled together in a vehicle. If I move on to some of the top features or some of the new features that were recently added in the software, the DEWESoft Combustion Analyzer has just recently had an overhaul, and we made a new user interface. We added some additional features, and some of these are to make measurement much simpler and much faster. So to start with, we now have predefined firing orders. So ignition misalignment doesn't have to be manually entered. You can just select a predefined firing order from the list if this is from a standard straight engine or an engine that has equal distribution for firing, or any custom firing order can also be entered, or any custom angle can still be entered. We also have an option to use cylinder deactivation. So this is our combustion analyzer was also done for any type of modern engine that also needs to be tested. And one of these things is cylinder deactivation. So each of the cylinders can be permanently activated or permanently deactivated, or this information can actually come from a CAN channel or from an analog channel. And this means that if you connect the CAN, which is available on every one of our measurement devices as standard, to your vehicle bus, and get the information of cylinder deactivation from the engine, then you can actually tell DEWESoft which cylinders it needs to turn off or keep them switched on. And the cylinders that are deactivated will then generate additional outputs that are not taken into account for the average value calculations. This can also be used if you have, for example, pressure sensors that have failed. You don't have to change the setup, but instead you can just set those deactivated and use the same setup. We also have different types of zero-level corrections inside the software, and this can be set for each cylinder individually. So if you have a mixed type of pressure sensors, you can use for some pressure sensors thermodynamic correction. For some of them, you can use a fixed value, and for some, you can even use no zero-level correction if the sensor itself already has this built in. So it's a possibility to use a mixed pressure sensor inputs. We also support now dual polytropic coefficient. So the first one is used for compression and the second one is used for expansion. We also have an output available which calculates the polytropic coefficient, and by calculating an average value or overall value, you can actually override the manual coefficient. So the software can automatically detect what the polytropic coefficient is and input and use that as an input. So a use case for this would be if you have a dual fuel engine where it switches from diesel to gas and vice versa. Normally you would have to stop the measurement, change the setup or change the polytropic coefficient, and then start the measurement again. In this case, where the software detects the polytropic coefficient automatically, you can just run the measurement non-stop and the polytropic coefficient will be adjusted according to the fuel that is currently being used. The software was also made to be used with engines that have variable compression ratio. So a text file which has multiple compression curves can be imported. And same as with the cylinder deactivation, here it's possible to read the data through CAN. And from that, get information which compression ratio is currently being used in the engine or how the geometry is changing. And through that, apply the correct volume curve and change the compression ratio as the measurement is being done. And the switch can start at start of each new cycle. It's also possible to run multiple combustion analyzers together. This can be used in some special cases where you're measuring compressors or you have engines with different geometries of cylinders. So this can be then defined in a single setup. We also have all the standard outputs available in DEWESoft with just a click of a button, and everything is located at the same place. So you don't have to apply or make any complicated formulas or link together blocks to get the desired output. Here you can just click and enable the desired outputs and also specify if you want to have only current values or running averages or overall averages and so on. And all the settings are located in one tab, so it's really easy to enable additional outputs immediately after that. One big benefit of DEWESoft is that if you do a standard measurement where you have also analog data recorded, when you go to analysis, even if you forgot some of the outputs that you wanted to enable after that, you can do this even if in offline mode. Since we have analog data recorded, we can just recalculate based on that data and do any kind of modifications we want to have. Statistics values are available as running averages for a certain number of cycles or as an overall average, which is basically calculating one average pressure curve, and out of that, recalculating the results. We can also calculate cylinder average, which is a single value output for a complete measurement for each cylinder separately. And we also have engine average, which is a current value of the measurement for all cylinders combined. We have also two options how to transmit all calculated data from Combustion Analyzer to third-party systems. In the past, the only solution or the solution that was used the most was CAN transmit. So each one of the Sirius boxes has a CAN port by standard on the backside, which can be used to receive or transmit the data. And in DEWESoft, it's possible to then generate a channel list, export to a DBC file, and on the other system, just import the same DBC file and immediately read the data that the DEWESoft system is sending out. Now, just recently, we also made the XCP slave plugin, which similarly as the CAN plugin, can generate the A2L file, which has a definition of all the triggering events and also complete channel list, and is perfectly compatible with third-party systems. The big benefit here is that with CAN, usually you needed some hardware to transmit and receive CAN data. With XCP, everything can be running on a single PC using the local network card, or even if you're using multiple PCs, you can connect this by using just one Ethernet cable, and you can transmit much more data also with a much higher rate. So you are not limited in how many channels you can transmit out of DEWESoft. Another option how to use DEWESoft Combustion Analyzer is also with the Testbed plugin. So the options that I mentioned before are mostly used for mobile applications. If you're doing measurements on the dyno, then usually you're in the testbed environment and you have a master system that gathers all the measured data and takes care of the calculations. So there needs to be some communication to this testbed system, and we have in DEWESoft a testbed plugin. So this plugin, in this plugin, you can generate a channel list to define which channels you want to send from DEWESoft to the other system. And in the other hand, the other master system can control DEWESoft completely. So this means that you only make the setup in DEWESoft, save it, and then the testbed control system can tell DEWESoft which setup to load, how many cycles you want to store for, which values you want to get, and also if at the end of the storing you want to export data to some other format. And this can be done completely remotely. So DEWESoft can be running completely remotely without the operator touching it or even knowing how to use DEWESoft. And we support the standard AK protocol or Puma, D2T, or Tornado through RS-232 or TCP/IP. Here's also a really nice example how DEWESoft can be coupled with other tools inside the software. So, for example, we have a really powerful electric power analyzer, and coupled with combustion analysis, this can make a really good hybrid engine analysis package, as you will see in the demo right after this. Combustion can also be coupled with torsional vibration, and this can be done if you just add an additional encoder or angle sensor on the other end of the crankshaft. Then you can immediately do shaft rotational analysis and torsional vibration. If you add just one accelerometer on the engine, you can immediately do order tracking of the engine and see where you have some harmful frequencies in the engine. If you add a microphone, you can immediately do noise analysis by using Sound Power plugin. And here on this example, you can see how high-speed video was coupled together by also measuring pressure inside the cylinder. And you can see really nicely inside the cylinder the swirling motion of the gases, and then also the combustion inside the cylinder. And you can see exactly in the analog signal when we had peak pressure and when we had then actual combustion in the cylinder. This year, we also have a plan to update Combustion Analyzer with some additional features. And like with everything at DEWESoft, once you buy the combustion analysis license, it's yours forever. Even if we do some additional updates, if you have an existing license with the complete package, you will get lifetime updates and you will have more additional features and a nicer package for the same price. So what we plan to do in a couple of months or at the end of the summer, we will add TDC detection in measure mode and analysis. So this means that top dead center detection can also be done in the data file later on. We're doing offline TDC detection. It's going to be possible to do TDC detection on fired engines. So this means that if you delay combustion after the first pressure peak, we can actually detect also TDC on that one, so you don't have to run the engine without combustion completely. We will implement a new knocking algorithm, which will have better knocking prediction for gasoline engines. Start and end of detection will be possible on every additional channel. Now at the moment we had only one start and end of injection detection event. Of course, it was possible to use multiple combustion analyzers in the same software to overcome this, but now it's going to be possible to trigger this on every additional channel and also have zero level correction on every one of these channels. If you have current sensors that have some drift, you'll also be able to select a window for detection. This means that if you connect one current clamp for 5 injectors, you have a combined signal with 4 peaks, and then you'll be able to just select a certain angle window on which you want to detect your injection signals. The output, of course, will be in start and angle, total time, duration in time, and so on. We will also add additional 2-stroke calculations based on scavenging pressure and maximum pressure, and also blow-by pressure for easier analysis of big 2-stroke engines. And of course, we will add various minor updates that improve the user experience and also make using combustion analysis much easier and more efficient. So I hope you saw that we have in the software support for all sensor types. I will now also show in the demo how easy it is to use the software and how portable and flexible the hardware is. We have perfect integration by using CAN, XCP, or Testbed with any kind of other system in the market. And we can have synchronized acquisition from multiple sources. So it can be pressure signals from the engine. It can be also microphones, voltage, current, and also combined with CAN data and everything else. And on our web page, we have completely free of charge online pro training help with which everyone can quickly get started on using combustion analysis. So at this point, I'll switch over to DEWESoft, and I will show on this small demo engine. Let me just here make the video a bit bigger. Hope that you can see this. I have here a small engine. This is actually from a weed whacker. It's a 4-stroke engine. We are measuring here the pressure signal. So this is actually a pressure signal that already has 0 level correction inside the sensor. On the back side, we have a 128 pulse encoder. And here on the front, we have a 3-phase electric motor coupled with this so that we can run the engine. I am now inside, so I cannot really start the engine here. So that's why we have a small electric motor that can motor this engine so we can do some actual pressure measurements on this. And together we're doing combustion analysis on this engine. We are actually measuring all 3 electric phases on this 3-phase motor. We are also measuring all 3 currents by using current clamps for this electric motor. And then here, where we have the battery connected for the motor, we also measure current of the battery and voltage of the battery. So this is basically how a hybrid powertrain would look like. You would have one combustion engine, or basically one combustion engine, and then either one or multiple electric motors. And here with DEWESoft hardware, we have 2 serious high-speed slices. So high speed go up to 1 megasample per second. And if you have a gasoline engine where you would like to have output of at least 0.1 degree, that goes to 6,000–7,000 RPM, then we need high sample rate to be able to accurately recalculate into that. On the backside of the series unit, we also have an analog output through which we can control the controller for this electric motor. So we send out a pulse and tell the engine when to run and with how many RPM. On the front, we have in the first input just a simple microphone connected, so we can measure exhaust noise. And here in the front, we have on the counter input, we have the encoder connected. And here we have the pressure signal connected to the STG input. So here we have just a voltage type pressure sensor. But this slice is a charge type input. So also charge type sensors could be directly connected to any one of these inputs. On the bottom, we have also one high-speed slice, which we call a power slice. So it has 4 times high voltage inputs that go up to 1,600 volts directly. So we have the first 3 are the 3 phases of the electric motor, and then the 4th one is the battery voltage. Here on slots 5 to 8, we have 4 low voltage inputs. And here we have the current clamps connected. And the current clamps are also powered directly from the amplifiers. So no additional power supply is needed for these current clamps. And the nice thing here is that they also have test chips in connectors. that is basically like an electronic chip that has the sensor database inside. So as soon as this is connected to a series instrument, the sensor is read and everything is set automatically. So all the scaling is set automatically, and the sensor type or amplifier type is set automatically via this. Here I have the setup already loaded. So like mentioned before, we have the microphone connected, cylinder pressure enabled, and then we have 4 voltage inputs and 4 current inputs. Combustion Analyzer is added here by just clicking on the plus button, and we add the CA module. There are 2 things that we always need to do when we add the new Combustion Analyzer. If I just click on the plus button here, I can show you on an empty Combustion Analyzer module. So everything is really intuitive, and you get immediately an error message, reference pressure is unassigned. So we can click on pressure signal for the first cylinder, we assign cylinder pressure, and the error message changes to trigger channel is not selected. So we go here to encoder settings, and if we are using one of the encoders on the list, we can just select it directly. Otherwise, we can also make custom sensors like encoder 100 to 128 pulses. We have this connected on counter number 7. As soon as we connect it, that's it. The error message is gone, and we can start with the measurement. Okay, so here when we have everything set up, we can just enable all of the outputs, and we can go to the measurement. So I'll just do here a quick measurement, and then we can play around with this in analysis. So let me just start the measurement, and here it's going to be a bit louder and maybe a bit more difficult to understand in between. So let me just run the engine a bit. Okay, so here you can see the recorded data file, and we'll just take the part where the engine has started up. We change the frequency. So what you see here on the screen is here on the right side, we have actual measured pressure data from this in the cylinder. Here in the middle, we see the RPM of the gasoline engine, RPM of the electric motor. And on the left side, we have measurements of the electric motor. So all 3 phases and also current and voltage of the battery and the total power of the electric motor. And through this, we could then also calculate what's the efficiency of the inverter and so on. For combustion, we immediately get all the calculated outputs. So what's the power, Pmax, angle of maximum pressure, what's the maximum rise, and also MFB 50 values. So in this case, we don't have any actual combustion inside the cylinder since it's being run with the small electric motor, but we still get the calculated outputs, although not completely valid. One really nice thing about combustion analysis in DEWESoft is, or basically most of the modules inside DEWESoft, is that once you have recorded data, you can actually do any kind of modifications, just go back and just recalculate the data. So this would be in the case if we didn't do TDC detection and the angle offset would be completely off, we could just enter the correct number and recalculate this data. Even if you would have thousands of measurements, you could just do this on one data file and then apply it to all of them at once. Same goes also for the displays that you see here. Everything is completely customizable, and you can adjust the display to however you want to have it. Even add some formulas, mathematics, other modules, and then apply those displays and mathematics to all of the data files at once. So here you can just change it back. We can even enable additional displays that additional outputs that we didn't have before, this additional statistic values. We could even add additional cylinders that we didn't have in the setup before. And one thing that we also measured or also had connected with this measurement, if I add a new recorder here, was a microphone. So if I zoom in a bit, we also had a microphone connected. But here we see just noise mostly that doesn't make any sense. Or we could also add the pressure signal. Then we could see some correlation between the pressure signal and this noise. But what we can also do is, and that's a nice feature of the Combustion Analyzer, we can add this microphone channel as an additional channel, and we can just recalculate the data. Let me just zoom out a bit so we have a bit larger area that we want to analyze. So this putting any channel or any analog channel to an additional channel for combustion will do two things. It will recalculate that channel into the angle domain. And in the same time, if you have multiple cylinders and those cylinders have some ignition misalignment, it will also shift that channel for the ignition misalignment that you have inside. So this is really nice if you are measuring fuel pressure or oil pressure, and then you want to analyze if you have some spikes from the frequency disruption of the engine as it's running. And you can add any kind of channel. You can even add measure channels from power analysis or directly from the measured power and current values as additional channels. So now that the data file has been recalculated, you can click also on the combustion scope and add this additional microphone channel. And now if we find here, let's say a part of the data file where the engine was running more or less constantly, you can also see that we had much higher noise here at the exhaust valve opening. And this is because the microphone was located here at the exhaust. And then here you can also see exactly at which point the exhaust has been opened and where you had more noise directly from that. So you can immediately analyze exactly where certain events or certain peaks or vibrations are coming from. So here, everything can be coupled together even offline. We could add additional channels like voltage, current. We could analyze any one of these channels directly with that. We also have input for start and end of injection channels. This means that if you have an injection signal or an ignition signal connected, you can assign here the input from the current clamp or from the signal directly, define how many injections you expect to have, and then define the trigger level. And Combustion Analyzer will automatically output the actual angle at which the first event was detected or when the injector opened, and it will also detect at what angle the injector closed itself. All of these settings that you see here can also be saved to an engine template. So if you have multiple engines that you are using all the time, when you make a new setup, you can just select it from the list. You don't have to input this geometrical information every time. But of course, you can save everything to a setup and have it directly in the software. Resolution can also be increased down to 0.025 degrees, so you can have really high angle resolution, although this will generate much more data, but it can be used also for really high detailed angle combustion measurement. If you touch here on the outputs a bit, we have all the standard calculations for maximum pressure and position of maximum pressure. We output the theoretical compression curve without any combustion inside the cylinder. Like mentioned in the presentation, we also have automatic polytropic coefficient detection. We can output the derivative of the pressure curve and output what is the maximum rise and at what position we have the maximum rise. Of course, we have outputs for IMAP and PMAP values, calculated work, power, and torque. And then we have thermodynamics 1 and 2. With the thermodynamics, we can also define what's the start and end angle of calculation, and we get the output for the immediate heat release and the accumulated heat release, together with all the mass fractions of fuel being burned at 5%, 10, 50, 90, and here user definable point that can also be entered. We also have an output for temperature and knocking detection, where we output the knock factor of the current measurement based on the pressure signal in the cylinder. So hopefully from this, you are able to see that combustion analysis is a really intuitive and straightforward tool in software. You are welcome to also check the pro training on the website, where you have an example how to set up Combustion Analyzer even without any actual hardware, to start playing around with the software and see how intuitive, easy, and versatile it is. And with the size of this hardware, it can be also the most portable solution used in a vehicle or on the dyno all at once. So thank you all for your attention. Have a nice day.
Thanks, Primož. Okay, everybody, now it's your turn. Using the chat option of your webinar viewer, please type your questions and send them our way. We will field as many questions as we can. If there are any that remain unanswered at the end of this session, we will do our best to reach out to you directly. And with that, I'll hand it over to Primož.